Welcome everybody to our session that we're having today. And we have a specialist joining us from the space industry. I'm not going to say veteran because you don't look old enough, Mike, certainly.
Thank you.
But you have certainly been very, very involved in the space industry for many years. And for those of you who popped in, Mike and I opened up the line a number of minutes early, and Mike mentioned that he was actually watching the live stream of the SpaceX launch that is happening right now. Well, not right now, but probably in 30 to 45 minutes from now, because he actually did a lot of the paperwork for many of those payloads that are on that rideshare launch today. So Mike, thank you very much for joining us. We're dragging you away from, I'm sure, another one of your launches that you're watching with many of your payloads on board. Mike is the founder, and he runs a business called Sterk Space. And today we're going to be covering the topic CubeSat payload and licensing considerations. Mike, thank you very much. And yeah, so we're going to have a number of questions for you. And I know that you've already had a look at some of the ideas that some of the participating groups are already thinking about for their suborbital launches. Which will eventually, those payloads will eventually, evolve to being CubeSat, orbital CubeSat payloads. So we're really starting to think about all of that right now. Mike, I'm thinking, let me hand over to you so that you can certainly share with us your experience, and we can start the discussion.
Okay, great. Thank you, Judy. I'm really glad to be with everybody today. It seems like a really interesting group, and Judy and I were just marveling at the variety of time zones that we all occupy, from Hawaii all the way to Central Africa. So some of us are having breakfast and some of us are after dinner. But here in Montana in the United States, I'm sort of in the middle. So I had a little lunch before we sat down together, but I hope you're all comfortable, and I hope you're all ready to talk a little bit about communications and space travel and regulatory and how all those things may fit into your futures. So I've got a few slides prepared. I'm just going to share screen now.
Great. There we go. Yes, there we go. We can see that, Mike. Thank you very much.
Wonderful. And Judy, if I can ask, because I'll be sort of thinking about what I'm thinking about, and I don't have the chat line up, if you can sort of give me a tug on my sleeve if there's some remark or question that I should be addressing, that would be great.
That's absolutely fine. What I'm going to do is I'm going to pretend that I have a very different culture from you and that it means nothing if I just interrupt you. So that's great, Mike. Thank you for permission.
That's not all that unfamiliar a situation for me, Judy, so that'll be fine. All right, so are you seeing my slides okay now?
Yes, we can see that you have a document. It looks like it's, yeah, it says the heading is regulatory considerations for small satellites. Yes, we can see that, absolutely.
Wonderful. Okay, that satisfies my presentation insecurity. All right, so regulatory considerations. As Judy pointed out, regulatory is a lot of what I do with respect to lots of small satellite missions. And I'm going to talk a little bit about communications and other things leading up to regulatory considerations. As you all know from your experiences with suborbital launches to date. The main thing that we're doing, the payoff, if you will, is that we acquire data with satellites. The data can be from sensors or from remote sensing. They can be data about the satellite or data about observations on the satellite. But getting the data back to the operators with radio transmissions is something that very many orbital missions have in common. And in addition, radio is used to control the satellite. If the mission operations on Earth wants the satellite to move to another phase or take some correction or do some other things, it's all radio coming up from the Earth. And radio transmissions all over the world require licensing. And in the US, in addition, leading over to regulatory, satellite imaging also requires regulatory review and possibly licensing. So if we're transmitting with a radio, or if we're taking pictures or videos of the Earth or of space from on orbit, those are all things that are under the purview of regulators. Now, why is that? Is that other than because it seems like the government does lots of stuff that annoy us, why do they regulate those things? Well, the coordination of radio transmissions is necessary to avoid interference. You know this from listening to the radio in your car. The way you change radio stations is to change frequencies. And all the radio stations have agreed on who would transmit on which frequency. And if two entities transmit on the same frequency, it can make a mess for both of them. So I've sort of boiled down the work of thousands of people globally with radio regulation to that one thought, is that we have to play nice together so that we can all hear the transmissions that we want to hear. So that's why we do radio transmission regulation. It's not because there's anything bad about it. It's because we just want everybody to have their own space. Okay, regulation of image data. That's more of an issue of national security or privacy. We know that there's lots of places in the world where people have things that they'd rather not have pictures taken of, or pictures beyond a certain level of resolution. I probably don't mind if somebody takes a picture from a satellite in space and they can see what color the roof of my house is. I'm not very sensitive about that. But if they can look over my shoulder and read the text on my phone while I'm standing in my yard, then I draw the line there. Well, everybody draws the line somewhere, and drawing the line is what regulation of remote sensing does. It says this is okay, and this is maybe uncomfortable for somebody. And both the coordination of radio transmissions is governed by international agreements, and to a degree, so is the regulation of image data. The United States has agreements with other countries, and other countries have agreements about what they do and don't take pictures of. So that's why we're talking about regulation for satellites. So again, looping back, why is it so important to talk about radios? Well, for most missions, data is the total payoff. You send that little bird out into space after you've spent months or years working on it, and you will not see it again, very likely, but you will have its data to treasure. You will have its the data and the pictures and the other things that it may send back to you. So that's why. Now, with suborbital missions, you've so far had a better time of it because you can physically recover your satellites, or I'll call them satellites, they're payloads. But with orbital missions, you don't get to recover them typically. So we have to get the data while the satellite is on orbit with radios. And so small satellites, again, the message here, support many types of missions. For virtually all the mission types, successful execution requires retrieving the data. And part of why I'm emphasizing this is not just to convince you that you will have a radio on your satellite, but to really, really beg you to make sure your radio works, because so many missions fail because the radios just don't work. So don't be one of those. Be one of the ones that works. The communication system essential for reaching any level of mission success. That's why we all did all the stuff we did on the satellite, is so that we could get some data back and we could have the satellite do things, and we need communications. And sometimes I'll riff a little bit on academia here. I went to school and I loved my professors, and before that I loved my teachers in elementary school and high school. I did. But I've heard some professors say things like, well, students should be allowed to fail. To which I say, but not the ones working on the radio. Because if the guy working on the radio or the girl working on the radio fails, nobody else has a chance. The one who worked on the sun sensor or the gyroscope or the biological experiment, they will never have a chance to succeed or fail because radio silence. So the comms can't fail. The other ones, yeah, I think it's better to learn to succeed than learn to fail, but I know that the other ones will never get a chance at bat if the comms doesn't work. Anyway, that's something to bear in mind. So the essential nature, I've anticipated this a little bit. So communications, you should think of, I'm saying you should think of as a utility. It's like power. You have to have power or nothing much happens. And a launch, you have to get to where you want to go or nothing's going to happen. And so we don't make experiments out of those things typically. We make them hard as nails. We make it works every time. And we steal like an artist, as the book title goes. We look around and see who did something good and do it like them or learn from them. And okay, more specifically, thinking about your comms topology, so to say, you want to think about whether you want to have your own ground station. Where's the satellite going to talk to? Or are you going to use someone else's ground station? And there's also the possibility that there may be no ground station at all that your satellite talks to. You can just have it talk to other satellites like the Iridium constellation, which is a kind of a cool alternative. And here's a diagram that sort of lays out the general case, all the ways that your satellite can talk. Your satellite can talk to the ground. Most missions do that. Okay, you have a ground station, maybe it's on your own campus, maybe it's on someone else's campus or some other place, and you talk back and forth there. Or you may talk back and forth to another satellite. You may launch a pair, 2 or more satellites, and they can talk to one another. Your own satellites can talk to each other. That really doesn't get you back to base, but that could be an experiment. Then you can have a third-party constellation. The one that really going forward that we're going to be using is Iridium for right now, but there may be others in the future. There probably will be. And that way our satellite talks to the Iridium satellite. The nice thing about that is there's lots of Iridium satellites. Your ground station, we only see for a few minutes, a few times a day, but there's always an Iridium satellite somewhere in the sky, and a satellite has a really big sky, so you can maintain communications this way just about all the time. So that's what we call persistent communication. We can, instead of having a pass over the ground station and we've got 8 minutes to get down 12 hours of data, we can be chattering away with the Iridium all the time almost. And then Iridium takes care of getting the data down to their gateway, their ground station, and then they would send the data by internet to your mission operations. So these are the 2 paths to get your data off your satellite and down to the ground. And of course, these work the other way too. Okay, so I've said we need to have radios and we need to have regulations. So how do we get regulations? Oh, all right. Sorry, I digress. Judy mentioned that the Transporter 5 launch was going on just about now. And my son, who works with me, just texted me, we have nominal orbit insertion, and they stuck the landing of the first stage as a bonus. So the first stage, which had been used 8 times or so already, gets to be used yet again. And we have nominal orbit insertions for the payload. This is a great day for 59 satellite operators. Cool, huh?
Mike, that's fantastic. That's absolutely amazing. Isn't it wonderful that we now have access to such services? And as you say, you said earlier, you know, we should regard kind of the radio as the utility, you know, as we would electricity or water or something like that. And what's so really great is that launches are also becoming a utility. And yeah, the more we can reuse, the more we lower the costs, the more we decrease the environmental impact. So yeah, that's fantastic news. Wonderful. Thank you so much. Please thank your son for sharing that with us. That's terrific. Congratulations.
I'll send him a thumbs up. All right, well, that's that. I feel pretty good. That's 59 satellites in orbit. Some of them have to work, right? No, we hope they'll all work.
As long as all the radios work, Mark.
As long as all the radios work, I'm going to feel pretty good. If the radios work, we'll know how well everything else works. And that's what we're here to do, is find out how things work. All right, so, all right, this is really good. And that's going to be the drama over the next day or two, is getting in touch, is looking for that first signal from the satellite that says, yes, the satellite can transmit and I can receive, and then I'll transmit to the satellite and it'll let me know that it received, and all the handshaking happens and we know that we are in business in orbit. So anyway, that is very fun. So, and I can promise you that all of them that I worked on have licenses. So, so what about that license? The operator of the site license. Oh, sorry, I'll start. I lost my place here. I got so excited. In the United States, all right, everybody who's not a government agency gets their satellite licensed by the Federal Communications Commission, which is an agency of the United States government. And in other countries, they do it other ways. Sometimes there's an equivalent of our federal communication system, and sometimes people correspond more or less directly with the International Telecommunications Union. I'll get to that. But the operator is typically required to show the license, some kind of license, as a condition for turnover of the satellite to the launch payload integrator. When you have built your satellite and it's time for it to go on its merry way, you will bid it a tearful goodbye at the gate of some facility and hand it to the launch payload integrator. And they will say at that time, or they will have said before, hey, you have to have a radio license, and you will produce the radio license. So that's really the reason you need that license in your own practical terms, is because you can't get on without it. You can't get through the gate and you'll miss your ride. It's just like showing up without a ticket for the train or something. You miss your ride if you don't have the license. So the timing is inflexible because launchers don't want to take a chance. One time I'm aware of a US related launcher launched without, and there were consequences. It's like when you mess things up in school, there are consequences. Well, there were consequences for the launch provider and for the satellite provider, and everybody felt bad. And as is sometimes the case, everybody had to endure tighter rules after that because this happened. So we don't want that to happen. And so US operators have two paths typically for radio licensing. This is amateur licensing and experimental licensing. Amateur means I'm operating as a ham, an amateur radio operator, which a lot of you know what that means. There's a worldwide organization of amateur radio operators, and they have lots of rules and they have their own governing body and things like that. Or you can, if you're using a different operation scheme, you can have an experimental license from the FCC. And experimental means it's not sort of licensed like a big Iridium satellite constellation to permanently do business in space. It's an experiment. It's something I'm going to do for a short time. And I sort of slip it in between the cracks of this big regulatory structure that takes years and years to grant commercial licenses to really big guys. Although we're working on shrinking that down too and making that commercial part easier, but that probably doesn't matter to you so much with educational projects. Those are not regarded as commercial. Globally, everything ends up with the International Telecommunications Union in Geneva, Switzerland, which is sort of a UN-related offshoot international body that keeps track of all the radio space transmissions in the world and nominally make sure that they don't interfere with each other. They make sure by publishing what you're doing so that everyone else can see it, and anyone who has concerns about being interfered with are able to write you a letter and say, hey, I have concerns. But even before that, even before your license is granted by the FCC will make pretty sure that they don't think you're going to interfere with anybody. But people still have the right to, and I get letters like this constantly. They're form letters from around the world, from agencies in different countries that say, basically, we're concerned that you might interfere with our stuff, so you have to talk to us. And I say, okay, thank you very much. I'm glad to hear about that. And we, of course, are concerned to not interfere with anybody. And can you tell me the specifics of your concern? And I never hear from them then, because they just send those letters out to make sure that everybody remembers that they're still there and they have rights, which we respect that they do that. And in the US, the way we talk to the ITU is through the FCC. The FCC gets all our paperwork and looks at it, and if they like it, they give us a license, and then they send on the relevant data to the ITU. So the loop gets closed. And in your countries, it may be different. There will be a different path, but it will end up at the ITU by whatever means. And remote sensing, not to overlook the video cameras and the person taking a picture of my phone over my shoulder, which I hope they aren't really doing.
Mike, sorry, I'm going to interrupt you.
Okay.
What I'd like to do is before we go off the topic of radios, I'd like to know if there are any questions. I can't see any questions in the chat, but I have a question of my own. It's very much a novice to this topic. Here I am. I'm sitting in South Africa, there've been a number of student satellites that have been launched, with the South African flag on them. They've been launched by various parties around the world. But the thing is that, so let's say if I was in a country which had never, ever, ever launched a satellite before, how would I know who to go to in my country? Would I go to, for example, the ITC website? Could I ask the people in Geneva, what sort of body would I go to? Or is there some kind of general rule that of who I would approach?
That's a good question. It's an excellent question. And it probably has as many answers as there are countries that haven't launched satellites. But most countries, if they don't have satellites, they at least have radio stations.
True.
And television stations. And I would first look to the branch of the government that regulates the radio stations, which is typically in maybe the equivalent of the Department of Commerce, for example, but it could be elsewhere. But I would look in country at the people who regulate the land-based radios and have that as a beginning point. And I hope that they would be able to comment, and their comment might be nothing more than, why don't you just talk directly to the ITU? Let's say, in one case, where if you wanted to go on a launcher in the United States and you're not in the United States, you're in another country, the launcher is going to ask you to have some kind of paper from some entity in your country that says, we don't have any problems with this, or this is okay with us, or if you did these 3 things and one of those is right to the ITU, then you're okay. You would want to work towards having something like that.
Great. Mark, that's absolutely great. Daniel has typed up a question here. He writes, I have a question. Is there a best practice that our students can follow? Is there a best practice that our students can follow? And in brackets, speaking as someone who is outside of the professional industry, to make the radio communication process easier or more streamlined? When thinking about designing a payload during the engineering design phase of a small sat mission, is there something we should look out for in particular? In other words, is there some kind of a best practice? Daniel, do you want to come in here, please?
Yeah, so I recognize that the phrasing of the question might be a little bit unclear as well, especially for those of you who are not K-12 high school teachers. So for me, in my specific capacity, right, for my students, one of the big things that we kind of look at holistically is the pathway as a systems engineer. So they do everything from the scientific mission design to then justifying what the engineering design proposal is going to be to then launch. So in that kind of holistic overview, is there something that they can be doing to be thinking about considering what kind of the end, quote unquote, end game might be for them to successfully be able to actually integrate their payload that they spend all this time designing and, testing and making sure it works properly, for at the last minute, them to be told, oh, this doesn't conform to this standard, this standard, this standard, right? So therefore it's not going to be able to launch. Right. And in the context of specifically regulations, as well as communication or communication regulations, right? Is there anything that you would kind of have those students particularly think about as they're going through the scientific mission proposal process or the engineering design proposal process, right? Which then might give them insight like, oh, we should make these changes now so that we don't have to make those changes later on.
Okay, excellent question, Daniel. And that is a key concept, I feel, is to begin with the end in mind, to understand that your radio requirements, they have to be licensable. But I would want to say 2 things. They have to be licensable, and it has to actually function, and it has to carry the data that you want to carry. Those are 3 really big bullets that I would put on the tasking of your communications team. And so starting with the first, typically the science team would come with data requirements, so to say. I would expect the science team needs to be able to, they sometimes have trouble with this, but okay, you have to work on it, is how much data do you need? How much data per day do you need to bring down? How many bytes? And and remember that nothing is free, so to say. The more bytes you have to bring down, the more requirement that imposes on your radio specification. So be smart about how much data, but that's called a data budget, as you probably understand. How many bytes per day do I have to bring down? So get that number, and that number is surprisingly hard to get, but try to get it and try to understand where it came from. Remember that calculation, bytes up and bytes down. And that will tell you whether a really little radio is good enough, little in terms of its carrying capacity, because radios carry data. I'll just say bigger radios carry more data per second. So that will tell you something about the characteristics of the radio that you need. And knowing that, I would then go look at, you can look on the FCC website, for example, and you can see hundreds of CubeSat missions that have gone up. And you can drill down on those and pretty quickly come to some conclusions about, did somebody do something that's similar to what you want to do? And, typically they're educational institutions, they're universities or high schools. You can reach out to them and say, hey, did it work? I read about your project in the database. How did that go? And that, to me, that is extremely valuable information, because whether they say it went well or whether they say it went poorly, it's valuable information. If they say it went well, then you may want to go deeper and find out how they made it work. So that's my reaction, is look at what other people have done, and things are published. I mean, people publish at the SmallSat conference, they publish at the CubeSat developer workshop where Judy just was. And people talk constantly about their experiences. There isn't as far as I know, there's not a really giant encyclopedia of everything you'd want to know all in one place. But the FCC experimental licensing website is pretty good for that. You can search on frequencies or search on other characteristics and look around, but also just look at conferences. That's kind of a long answer. So Daniel, do you have a follow-up question?
Yeah, I actually just put it into the chat, but I was going to ask you if you could go into a little bit more detail specifically about what you were talking about with what kind of data or the actual data that we want to carry in the context of scientific missions. So you kind of touched on it briefly, right? But is there a difference between the amount of data that is transferred versus the rate at which that data is transferred? Right, so could you give some examples potentially that might give context for what maybe sensor data might be versus what students might be more inclined to want to see, which might be something like a video stream, right? And are those going to require different licensing procedures? And if that's the case, how would that then help them determine, like, we should pick this product versus this product?
Sure, okay, good clarification. I would say this. The data budget tells you how many bytes per day you want to bring down from all sources. And those could be video, and they could be, what was the temperature of my solar panels at 2 o'clock GMT, or they could be what was the opacity of the bioculture that I'm growing, or what was the rate of spin of my satellite. That, there's all these numbers that you want to bring down. For the comm system, they're just numbers. It's just digital content. And so what really matters is how much per day you want to bring down. Now, once you give that to the comms team, they sit down and say, well, let me see. If I have one ground station here at the campus, and I figured out I can get 2 passes per day, and a pass will be about 8 minutes duration on average. Then I've got 16 minutes of transmission. And the science team just told me I've got to bring 16 megabytes down. So I know I've got to have at least a megabyte per minute, or the books don't balance. It's like teaching budgeting. If I make $100 a month, then I pay $5 a month for sandwiches and $10 a month for books. That's like, it's a classroom exercise for students. just it has to work. I've got to get all the data that I want into 16 minutes if I do it that way. Now, if I had a second ground station that's in a different part of the pass, I've got 32 minutes all of a sudden. I doubled it. And if I use the Iridium constellation, I can maybe pass data for, 16 hours per day. But I can't go as fast because the Iridium's going to be limited on how many bytes per second or bytes per minute I can pass. So you have those trade-offs, and then you're beginning to do engineering. When you begin to do trade-offs, you're saying, I need to accomplish this. I have these knobs that I can turn to get to accomplish it. And then you're into radio design, and I cannot cram how to do radio design into this discussion, but that's what they will end up learning about, is that a certain modest radio can pass so many bits per second, and a bigger, better, more powerful radio can pass more bits per second. So there's a trade-off between how sophisticated your radio system is and how much data you bring down. And if the comms team can push back on the science team and say, hey, can't you guys summarize a little bit? It's like the English teacher saying, yeah, all right, here's 2,000 words, but I want you to condense this into 200 words. Well, that would be a challenge that might be put to the science team. How do I put all the information I really need into 1/10 of the bits that I said I wanted? Does that make sense? Maybe another follow-up?
No, I think that's pretty much answering the question in a nutshell, right? So you're essentially saying, doesn't matter what it is, at the end of the day, what is needed has to be equivalent to what can be collected, right? So it has to be equal on both sides. If the equation doesn't equal, then you're either losing data somewhere, or you're asking for too much of whatever the bandwidth available is.
Yeah,
right?
it's just, that's right. It's just, it's a delivery problem. It's like, yeah, like I'm delivering groceries, and how big a truck do I need versus how many groceries have to be delivered versus how long do I have to do it? It's, there's lots of metaphors in everyday life, but yeah, it gets people into the idea of trade-offs. And I think that's an interesting way to teach.
So just to kind of wrap it back to you, actually, real quick, in the context of specifically thinking about licensing, then, if the bigger the amount of data required is, right, I'm assuming that would be a different potential quote unquote frequency or different way of making that communication happen. Do those licensing requirements change?
Not necessarily. I'll say that. I mean, you can always, if you say, geez, I'm gonna pump down, 20 terabits of data in a day, then you need something like PTD3, which was one of the payloads that launched today, that has an experimental laser communication system on it, which isn't even radio, which invalidates everything I've said about radio, but they don't sell those yet. So for now, we're stuck with radio. In most cases, for education class satellites, you are going to be constrained by the amount of power that you have and the size of your antenna to probably a certain class of radio that will not be problematic with regard to licensing. And if you use equipment that's widely available, then you're probably in the same boat with lots of other people. You're going to be looking at either UHF downlink or S-band downlink, very likely. It's going to fall in one of those categories. And there's a broad history of licensing these kind of experiments in those areas. So although it's important to understand how much data you're going to carry, it doesn't affect the difficulty of licensing by that much for most education class satellites. That's my qualified answer.
Mark, Daniel, thank you very much. Cassie, you have a question.
Mike, so I teach K through 5. I like to think of us as the New Beginnings group. And I had a question regarding the application process. Is there a different process for educators and students at like this grade level, different than, you know, professional application process? Like, is the process of licensing the same? No matter, like the application doesn't change based on education versus non-education, age level versus professionalism? Like, is there anything in terms of licensing that I need to be aware of, especially teaching a K through 5 for licensing?
This reminds me of something that a gate agent at an airline said to my wife, who was a retired teacher, some time ago. And what she said that I still remember is, teachers never get a break. And sorry, yeah, you can maybe relate to that. And, you know, at that point, she gave my wife an upgrade just because of that, because she thought maybe a teacher should get a break sometimes. Now, unfortunately, you don't get a break with regard to regulatory. There isn't any different license for K through 5. It's the same system, the same process, the same everything. And I you know, as Judy knows, you know, I help out a number of different entities like that. I've worked with grade schools and I've worked with high schools and I worked with universities. It's all the same paperwork.
Okay.
But I hope that the next time you travel by air, you're treated well, nevertheless.
Absolutely. That's why I drive. Thank
Wonderful. Wonderful, Mike. Thank you very much. Cassie, thank you for that. We have a question as well from Sanskrit. I'm not sure if you want to actually ask that question yourself. It's a really great question.
No, sure. I'll ask the question. So this is like kind of like two different questions. I just lumped them into one message. But so what's the single biggest like pitfall, right? In like what's the single biggest problem like in regards to radio and satellites, not just like regulation wise, but also like technical aspects of like how the radio itself works and whatnot?
The single biggest problem that the missions I work with have is they don't have anybody on their team who knows anything about radios. I don't know if that's the kind of answer you wanted, but looking across lots of missions and, you know, dozens and dozens of missions, the problem is that, you know, at the university level, for example, they teach electrical engineering and they teach mechanical engineering and they teach computer science, but they don't teach radio engineering. And nobody knows anything about radios. You could probably sense that's my ongoing frustration. And if you ever get anybody who knows about radio, he leaves halfway through the project and nobody knows what they did. Anyway, it's very easy for radio to languish just because nobody understands how to get started. And so I would caution against that. Try to get your radio resource nailed down as early as possible. One of the best places you can go looking for people who know about radios is the amateur radio community. Amateur radio operators know lots about radios. If you can get one who's interested in your satellite project, that's very helpful to mentor the students and add some critical mass to your team. Now, going a step beyond that and saying, well, but Mike, that's an organizational problem. What's the technical problem that comes up a lot? The sort of moving closer to the technical problem, the next problem is not testing. It would make perfect sense to you that if you have a ground station and you have a satellite, that you would want to try having the ground station and the satellite talk to each other, but you'd be amazed how often people come up with a reason why they can't do that. Yeah, but they think it'll work. They're pretty sure. The person who sold them the radio said it would work. And they saw the lights get all green one time, so what do you want? anyway, testing is really, really important. Yeah, design is really important, but testing is really, really important. You have to put the room in your schedule to test. And the reason a lot of people don't test is not because they are stubborn, it's because they run out of time. And testing is obviously the thing that happens at the end, after you have it all built and everything's ready on both ends, everything's ready at the ground station and everything's ready with the satellite, then you can test it. But that's at the end. And if everything else comes in late, there's no time to test. So really, really try to have testing be part of your project and part of your life.
Great, Mike. Absolutely, really, really good points. Yeah, we can't go too lightly when it comes to testing. And a little bit of an anecdote from myself is that every time we make a prototype of our boards, of our sensors and things like that, what I do is that I test them because I wasn't involved in the design at all. What I do is that I'm not emotionally attached to the design or the manufacturer or anything like that. But what I do is that I make sure that I test it over a really long period of time, because sometimes you find if you just do a test, oh, it works, oh, that's fantastic, okay, I've done that, check that box. What I found is that there are challenges that can crop up over time. And you know, I had this. I was testing a prototype over this weekend, and everything was fine. And then it started crashing on Monday, and I realized that what was happening is it was very, 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 very gradually. It was getting warmer and warmer and warmer and warmer. And you know, and then it got to a certain temperature where you know, the current started to there was too much resistance, you know, because it was just getting too warm. And you know, so the thing is that that's what we have to do, is we have to test in very cold temperatures, in very warm temperatures for long periods of time. We have to drain those batteries and recharge them and drain those batteries again and again. Because, you know, power and communication are they so tightly meshed, because that's what you, in a way, what you're doing is you've got this wave, which is also energy, you know. So so yeah, thank you very much for that.
Judy,
great.
I just want to
Yes.
add that on what you said. The other thing to emphasize about that experience you just related is the importance of the independence of the tester from the designer.
Yeah.
Because one of the things that can often happen, if the designer tests it, the designer knows how he or she meant it to work, and they will test it that way. And when Judy comes in and tests it, the designer says, well, I didn't think you wanted it to do that, right? They would never have found out if the designer had been testing it. The testing can flush out weaknesses in the specification, in the functional requirement, where you thought you told the designer what you wanted, and the designer thought that they heard that, but something was missed, and testing can bring that out. And that's one of the reasons why testing, and this came up with a NASA mission I was working on just last month. I said, we have to test early enough that if it fails the test, we have time to do something about it. Now, you think, yeah, well, that's logical, but you'd be surprised how easy it is to just say, yep, and then we'll test, and then 3 days later we'll ship. And okay, that sounds good, but as long as nothing breaks when you test. So anyway, test early often, and as Judy pointed out, for prolonged lengths of time.
Yeah, thank you.
Absolutely. Great, Mark. Yeah, thank you. Thank you very much for that. We have got some more questions. Krish, would you like to ask your question?
Yeah, so my question was if you knew any open source to fight the CubeSat simulators for the flight dynamics of the CubeSat, because that's also important, knowing how the CubeSat will react in space.
Sorry, open source, and then I didn't catch the last word.
If you knew any open source CubeSat simulators for getting a preview of how the CubeSat will operate in space.
CubeSat simulators. Well, there's lots of software that simulates different aspects. I mean, like STK, for example, simulates orbital behavior, and there's finite element and thermal simulation models. I guess I'm not sure that there's any that would be as holistic as to simulate the entire, all aspects of it. My experience is that you would use different modeling software to simulate different aspects of the device and of the mission. Does that make sense at all?
Right. So for the orbital aspect, do you know any simulators in general for that specific aspect itself?
Okay, for orbital, STK is great if you can get your hands on it. It's pricey, but sometimes education institutions get a break. Teachers actually do get a break with software. But so STK is good. Let's see, what aspect of orbit do you want to simulate? Do you want to simulate, say, orbit lifetime?
I mean, that's one of the things, I suppose, but orbit lifetime, and also, yeah, I think just that.
I'd say orbit, okay, orbit lifetime, there's, NASA has the debris analysis software that does orbit lifetime, but it's a little hard to get your hands on, but you may, depending on where you are, you may know somebody in the space business who has access to it. Nova is a good software that's quite reasonably priced that can simulate orbits. For example, if you punch in the TLEs, it'll tell you what point on Earth the satellite will be over at a particular time, which is a handy thing for planning your passes and for looking at the duration that you'll see for any particular pass.
Okay. All right. Thank you so much for your help.
Absolutely, and just have a look. Mike Galvin's put some links in the chat, their number of links in the chat if you just want to go and have a look at that. But Chris, thank you very much for that. Mike Galvin, let me hand over to you in terms of your question. Hi, Mike.
Hey, Judy. Hey, Mike. Interested about the future of LoRa in orbit. What you think are the pathways and timelines, and if you think there's already an existing sort of turnkey framework for licensing LoRa in orbit, or if that's still in development, and if so, what do you think the timeline is?
Okay, well, I would say that, good question, thank you. I would say that the turnkey license is sort of the holy grail of regulatory, and it's probably about as hard to find. Yeah. So,
okay, well, I'll call UHF and S-band. Let's call those turnkey, and maybe on a scale of 0 to UHS and S-band, where do you think LoRa is?
Okay, I'd say, we've licensed some LoRa operations, so it's not impossible. It's not that much more difficult than others. The place where it's interesting you should ask, because just yesterday I had some dialogue with one of the guys who sits on the International Amateur Radio Union Satellite Coordinating Committee, the IARU SAT Coord, in other words. And these are the guys that if you want to use an amateur frequency on a satellite, you need to write to them and say, here's what I would like to do. what frequency shall I use in some particular band? And then they write back and say something. And usually they say, they give you a frequency eventually. This takes several months, so you want to give yourself time. But if you're talking about LoRa in the amateur bands, they have some concerns at IARU. They have concerns about the bandwidth that's occupied. LoRa tends to occupy lots of bandwidth compared to other solutions. And there are some people who, again, they make it tough for everybody. Some people who are actually doing pre-commercial development who sort of paper it over as being educational. And of course, commercial stuff isn't supposed to use amateur frequencies at all. But there's some sensitivity on the part of the SAT Coord committee as far as these guys kind of, you know, taking advantage. With educational things, there's specific clauses in the IARU charter that allow for support of educational activities, and they're typically pretty good about that. But they're a little less good about LoRa. But they're just, I think it's new enough that they're still trying to figure out how to make it look more like amateur to them. Things like the tiny GS network and stuff. They're saying, well, I don't know if that's exactly an amateur activity or not. So anyway, I'm not giving you any specific answers because it's a topic on which I still have questions. People I work with have used LoRa. I'm kind of getting the signals that we've got to have a clean act, so to say, if we bring it in front of the IARU. Follow up?
No, thank you.
Great, Mike. Thank you very much. Many questions coming through just on this topic of radio. I'm a little bit concerned because we're getting to an hour of our time together. So I'm wondering if I mean, Mike, are you happy to stay a little while longer? Because I know that you still wanted to cover remote sensing.
I'm okay,
or would you like to do another session? If you think it's as big a topic with as much, you know, maybe we should schedule another session. It's completely up to you, actually.
You know, let's, there's only a couple more slides and proportionally a couple more thoughts to share.
Okay.
So let's go into those. I'm happy to come back and talk more later if it seems like it's worthwhile for everyone. But let's, if everybody else is good for a few minutes.
Okay.
It's one of those things where you feel like you have hardly anything to say, and then it, you know, fills up the time and more. So
exactly.
You know.
Absolutely. Well, that's because you're an expert, you see. So that's why. But yeah, great, wonderful. Back over to you, Mike.
Okay, thank you. So the other thing that we've just touched on and more lightly is the remote sensing, which is principally for US operators. The regulations on your remote sensing activity will vary greatly, and I have little to tell you about what would happen with your own countries, you know, in terms of licensing remote sensing. I will say that if you're going on a US launch, you want to have, just as you want to have an understanding very early on of when the launch provider wants to see that radio license, you need to also have an understanding, if you have remote sensing, of what they want to see for a license there. And then, you know, that's a conversation that you have to have. And that may come out with them saying, well, look here, you have to do this or you have to do that, or maybe you don't have to do anything. So in the US, though, which I'll stick to, this is the breakdown. There's this 4 levels deep of government agency inside of the Department of Commerce, inside of NOAA, inside of the Satellite and Information Services. We have the commercial remote sensing regulatory affairs people who have the challenging task of trying to not get in the way of innovation while still implementing guidelines that preserve national interests, so to say. And it's very much upon them to do that, because if other countries don't impose the same, or if other countries make it a lot easier to develop remote sensing than it is to do in the US, then guess what? Pretty soon the US isn't as good at remote sensing. And that wasn't the answer we wanted. So, so anyway, what we do, and CRSRA has done a lot. I was in a number of meetings with them, and they've done a lot with streamlining the process. That's the good news. So you have an initial contact form that you fill out online, and it will take you 15 or 20 minutes to do. And just one quick moment. And they will then, from that initial contact form, determine if a license is needed. And if it is, they now have a tier system, 1, 2, or 3, with 1 being the least burdensome. And typically, I would expect that educational activities would fall in tier 1. And so the license application you would need to prepare would be not too intimidating. But it may require 4 months or longer. You have to go into it with that in mind, that although for a tier 1, it would probably take less time, you want to, like with all regulatory things, allow as much time as possible. Okay, and one of the things that they are going to focus on is data protection, saying, well, fine, if you get your pictures, you've told me how you're going to protect them, you'll have them on a password protected server, and do you encrypt the data as it comes down so that other people can't listen in and put together your pictures, that sort of thing. So it's something to remember. There is, in the US, there is this requirement. And bouncing back to the regulating process, to summarize, we've got 2 paths, amateur or experimental. Amateur, we have to meet the amateur criteria, and we have to coordinate with the IARU. If the experimental, the other path, if you're going to, you can use any frequency for experimental, or at least you can try to use any frequency. But if you try to use an amateur frequency, the FCC anyway will tell you to go to the IARU first and get coordinated. So let's be prepared to talk to the IARU if you want to use an amateur frequency. And all transmissions from space, from any country, needs to be licensed and needs to be filed with the ITU. In the US, the FCC is the intermediary. You go to the FCC and the FCC will get everything from you that you need. A key value, you must have positive control over your transmitter. That means you can't have satellites flying around just deciding to transmit whenever they want. You need to be able to turn it off, because all experimental licensing is under the understanding that it's a non-interference thing. If somebody with a higher standing license says, hey, you're making things difficult for me, then you say, okay, I'll turn it off. So you always have to have means to turn it off. And last thought, the ground transmitters also require a license. Where you're transmitting from the ground to space, that will require a license in whatever country the ground transmitter is located. So the last and most important subject is timing. I touched on this before, but we want to start early, and because we can't be late. We can't be late with this or we'll miss our ride. So start at least 4 to 6 weeks before launch date, plan to have the license. And if you're going to the FCC, plan to start your application 4 to 6 months before you need the license. Okay. And again, one more time, learn from the common designs of successful missions. Steal the ideas, avoid inventing for your primary comm system. Just like, yeah, if you're going to the store, you don't need to invent how to build a car to get to the store. Just use the car you've got. Just use one that somebody else built and go to the store. And you will bring the groceries home. and you will bring your data home. So that's it for me. That's the last slide. That's my last thought. I'm happy to take any other questions, or maybe there aren't any other questions.
Mike, that was very, very interesting. Thank you so much. And yeah, I really like your analogy of use a vehicle that's been built by somebody else. Don't try to build your own. Yeah, and and the thing is that for me, what I learned through my career is that we never get anything given to us on a plate. We always have to earn everything. And if we want to make a really complicated satellite that's going to do these like really complicated jobs and all of this, incredible data and, these massive payloads, we have to earn that. And the way we earn that is by demonstrating that we can actually put something very simple into orbit and that it can all work. And then we can go on to the more complicated payloads. Because too often what happens is that we get so bogged down by the design, and then we find that there isn't a battery large enough in the universe to actually run that payload or run that radio to download all that data. So yeah, thank you very much for that. And also what I also realized when you said that you need to have a license for the ground station as well. That is what makes something like an Iridium solution so attractive. I shudder to think what it would take to get a license in a country where not really used to doing it for both a satellite as well as a ground station. I think that would be really difficult. And just for those of you on the bluShift suborbital program, I think now perhaps you can see why we've made sure that from a communication perspective that your data is going to be saved on your SD card. Most of your data is going to be saved on your SD card, and we're all going to be linking to one downlink that we are getting from bluShift. Because they are getting the license for that radio transmission, so that we don't all 60 odd of us don't have to actually go and get our own licenses and all of that kind of thing. So what we're doing is we're trying to remove as many barriers as possible without compromising the science that we're trying to do, and without we're trying. Also the thing is that it doesn't help learning how to overcome red tape if you're only going to do it once or twice in your life, And I guess, Mike, that's why you have a business, is because this is your business. But thank you very much for this advice, because I know from our conversations that we've had is that even the most professional groups still come at the last minute to you. And things need to be rushed through, and people miss the deadlines, they miss their launches, and all of that kind of thing, because they actually just haven't got the paperwork in place. And isn't that a tragedy to miss a launch because you just don't have the paperwork in place? So yes, Dr. Mensah, you asked, do we need licensing for the suborbital launch? No, you don't need your own license, so don't worry about that. But certainly bluShift, they need the license, so they are arranging the license, and that's why it was very important for them to find out from us what was our requirement. They gave us a budget, and that is why we're also limited in terms of how many payloads we can have in our portion of the payload bay. It's not unlimited because we've been given a budget. A data budget. We've also been given a power budget, so we have to comply with both of those. Good. Are there any other questions for Mike? Okay, Mike Galvin, would you like to ask your question?
Yeah, sorry, I was waiting to see if anybody else would have anything more important. But yeah, the question is about the kill command. The uplink requirement is pretty hard. It's pretty hard to meet, pretty hard to test for on the ground. And I think myself and a lot of us are interested in ultra short missions like the ThinSat mission on the order of days or even hours, and always wondering about the possibility of relief from the uplink requirement and what you think are the prospects of such a future mission class that is relieved of the uplink requirement in ultra low Earth orbit, short duration, those sort of qualifiers.
Right. Well, as it turns out, I've probably, well, I've worked on most or all of the ThinSat missions, and as well as a mission that well, put it this way, remember when we achieved orbit with Transporter 5 today? The mission I'm thinking of, Mars Outpost, it's over by now. It was absolutely necessary for Mars Outpost to have a kill command. Trying to do it without a kill command was a total non-starter.
You mean technically or regulatorily?
What do you mean?
So why was it a non-starter?
Well, because the regulations say you have to have an uplink.
Yeah, that's what I'm asking is, but was there any practical reason it would have been reckless without a kill command?
Different question. Okay. Yeah. The question you ask is a matter of opinion, I would have to say. But the fact is, you have to have a kill command, period. Even if the mission's only 90 minutes long, you have to have a kill command or you don't get a license. Now, a license isn't a technical requirement. It's a regulatory requirement.
Yeah.
So I would like to offer you more hope, but that would not be realistic. That's the concept of positive control runs right through the veins of regulatory from the US up to the ITU. It's one of the fundamental underpinnings of international law that govern operation in space is the concept of positive control. And thus far, nobody has been willing to let the camel's nose get anywhere near the tent.
Yeah.
Just like I say, I wish I had better news for you, but that's not the way it is. It's a fundamental. It's a guiding principle. It's a number one commandment. I don't know how else to put it, but no, you have to have a kill command.
All right.
If you have a transmitter.
I will remain on this soapbox until we believe otherwise.
You can go for it.
You know what, Mark Galvin, I'm very pleased that you do have a soapbox because it's much better than you being on my back because I know how persistent you can be. So yeah, thank you for that. Yeah, that's one of those things, you know, sometimes it's just there's just things we just can't get around. So we just have to plan for it.
I'd offer seat belts and crash helmets. There are situations in which you absolutely don't have to buckle your seat belt. You absolutely would be safe without buckling your seat belt. You can still get a ticket if you don't have your seat belt buckled. So
yeah, I guess I'm just there. I mean, there is a pretty good recent history of getting relief to different frameworks for amateurs and educational institutions. And I think people are getting used to thinking about these missions in different ways in different classes. And I'm wondering if there's another mission class here that is not being considered yet. And I will stay on this soapbox.
Well, I think it's great. I wish you every success. you could imagine a world in which there were other mission classes, certainly.
Yeah.
And
But it's not today's world. I got it.
Excellent, wonderful. It looks like we don't have any more questions. Mike, thank you once again. This is really, really terrific. If you are able to just share any notes with us, that would be absolutely wonderful. Daniel is really good at putting together, a teacher's note. So that would be great. But I'll follow up with you directly in that regard. So yes, thank you very much. And it was really terrific, and it was really nice actually to see a big crowd in the room. And that's because of you, Mike. Thank you so much.
well,
Good.
it was great. It was great to be here, Judy. It was great to, this was a good day because we launched Transporter 5 and it achieved orbit, and it was an even better day because we could all be together. So it's been a great day for me.
Wonderful. Mike, thank you so much. And to everybody, thank you very much for joining us. And any suggestions of topics or otherwise, if you've got further questions for Mike that you think about afterwards, please pop me an email and we can get those through. So I think with that, thank you, everybody. And we will see you next week, probably with another talk and another topic. Mike, thank you once again. Thank you so much, and congratulations on your launch and your mission today.
Thank you, Judy. Bye-bye, everybody. Please let me know if you have questions, forward through Judy, and we want to help in every way we can, because the work that you're doing is extremely important, and we totally support it. So thank you all for the good work that you do. And I can't overestimate or over-describe the importance of what you all do. So keep up the wonderful work.
Great.
Bye.
Mike, thanks so much. Cheers. Cheers.